Tips. Welcome to Hot Tips number 7. Machined contact crimping. Once crimped, machine contacts are typically used in connectors as mating surfaces. They use a specialized installation tool which usually pushes the pin in from the backside of the connector until it locks in place. In our previous videos, we learned about wire preparation. We also learned about ring terminals and how to select the proper tooling. Now we're going to take a look at machined contacts and the importance of circular mill area. When watching a machined contact crimping operation, it looks quite simple, but we'll take a couple of minutes and look at some of the details that affect the quality and reliability of these crimped terminations. Tooling is everything with crimped terminations. On this first image, we see the entry hole on this crimp tool is open. On the next image, we see the entry hole now has the indenters visible. This means that the handles have been ratcheted in so the indenters would crimp the machined contact. Let's take a look at the indenters as they're working. Now we've seen how the crimp tool crimps the contact. So what happens with this crimped connection? Well, when the crimped portion of the contact grabs onto the wire, that gives us a mechanical connection. And of course, being metal to metal, if we have a good mechanical connection, we probably also have a good electrical connection. The mechanical connection is pretty easy to see, but how do we know that we get a good electrical connection? The way that we do that is through two things: a cold weld that gives us gas-tight integrity. Let's see how this cold weld works. Let's take a single strand of wire. Since it's a nice conductive piece of metal, it's going to get a buildup of oxidation on the surface. Now we'll bring in another piece and we'll butt them up together. So at first, when they hit each other, they're just two oxidized pieces of wire. When we apply more pressure, you can see that they start to get deformed and have more intimate contact in between them. This pressure takes all the peaks and valleys and levels them out so we get more direct contact and displaces the oxidation. This is what's known as a cold weld. Now, how do we check and verify that we have a good cold weld? This is where gas-tight integrity comes in. If we were to use a gas that can get into any little crack or crevice and cause tarnish and applied it to this connection, what we'd find is everywhere where that gas could hit on the conductors would be tarnished, except for those areas that are crushed together with a cold weld, giving us gas-tight integrity. To get a better idea of how all this works, let's look at one of our case studies, Three Bears Cable Company.
Someone's been at my station and this contact is crimped too soft.
Let's take a look at what Mama Bear is talking about. In this first image, we see a machined contact that has not been crimped. This next image, it has been crimped, but just barely. And as we see in this following SEM micrograph, the strands of the wire are barely contained by the crimps, and we don't have enough pressure to give us that cold weld or gas-tight integrity.
Someone's been at my station, and this contact is crimped way too hard.
Papa Bear is right. This unfilled contact has been squeezed completely shut. Imagine what would happen to any wires that were in that crimp area. On this SEM micrograph, we can see that the strands have been compressed way too much. This elongates the strands and makes them weaker and actually affects the electrical operation.
Someone's been at my station and this contact is crimped just right.
Exactly right, Baby Bear. When we have the right contact, the right conductors with the right CMA match for that contact, and our tooling is set up for that specific crimp, we will get a crimp that is just right. Not too tight, not too loose. It will give us a nice firm mechanical connection and an electrical connection. This SEM micrograph shows that the strands have been deformed at just the right amount to ensure that we get a cold weld without excessive deformation. Now that we know all the background of the crimping process, let's go through an actual crimp and see how it's done. On this particular crimp tool, all the information we need for the proper selections is printed right on the turret. In this case, it says contact size 16 through 20. We are using a 16 gauge contact. It says the positioner and mating end color should be blue, and for a 20 gauge wire, it should be 4. Here we are placing the selector to 4 for our 20 gauge wire. Next, we open the positioner, and for our 16 gauge contact, we set it to blue. Now we flip the crimp tool over and drop the contact into the entry hole. We now take our wire and place it into the barrel of the machined contact while it is in the crimp tool. We can go ahead and compress the handles till it ratchets all the way through the cycle. And once we release, we can remove the wire and the crimp termination and do an inspection. It is now time to look at some acceptance criteria for crimped machined contacts. The first thing we'll look at is the insulation clearance. We would like a very small gap between the insulation and the machined contact. Half of a wire diameter is what we would consider target. In this case here, this looks just about half of the diameter of the wire. This would be a target condition. We next look at the actual crimps themselves. They seem to be centered in the crimp area, not off the edge towards the wire, and not down over the inspection window. They look even. The next thing we'll look at is the inspection window. In that inspection window, we can clearly see the strands of the wire. This lets us know that the wire has been inserted at least far enough so that when we make that crimp, we are crimping the wire strands. Do you see anything wrong with this crimped termination? Actually, there's 2 things wrong with this crimped termination. One is the insulation does not have a gap. It's not flush with the end of the machined contact. and 2 is wire strands are not visible in the inspection window, and as a matter of fact, insulation is visible in the inspection window. This tells us that we not only crimped the strands, we crimped the insulation also. Sometimes when we're inserting a wire into the terminal while it's in the crimp tool, a strand may catch on something and get bent outside of the contact. The crimp is completed, and now we've got a strand sticking out. Some people try to avoid this by using an alternative method of inserting the wire into the contact first and then putting the contact into the crimp tool. This crimped machined contact has no evidence of wire visible in the inspection window. In this image, there was something wrong with the tool settings, and the crimp has actually crushed and deformed the inspection window. Depending on which specification you're working to, the insulation clearance on this crimped machined contact may or may not be acceptable. Regardless, it's a little bit greater than we want to see. This is the end of Hot Tips number 7. You should now have an understanding of what constitutes an acceptable machined contact crimp. You have also been shown why the correct CMA and tooling is so important for a reliable crimp. Be sure to contact any of our training staff if you have a question you would like to see answered in a Hot Tips video. Make sure you check YouTube, Facebook, or LinkedIn for the next phenomenal episode of
Hot Tips.
We hope this brief video gives you some idea of our capabilities in the training department. Whether you need customized training, industry certification, online training, training at our facility or yours, we can do it. STI. This is the training you deserve.